Okay, let's talk about the limit laws. So we've already kind of discussed what limits are by looking at graphs, by looking at tables of values. Now we're going to learn how to do limits algebraically. So all of these laws that are going to be written here, you can just take as already proven. We're not going to bother proving them. You're allowed to use them from this point forward. And at some point, you should write these all down in your notes. Like, don't try to do it while I'm talking. Go back and watch this video, pause it, and write all these down. And I'm just going to run through them really quickly. The first one says the limit of x, that's your entire function, it's just x. As x approaches a, what does x approach? It should be obvious, it's just a. And the second limit law says if you've got yourself a constant function, if y always equals 5, then all your limits are 5. The limit of a constant is just that constant. So the limit as x approaches 2 of just x is 2. The limit as x approaches 2 of the constant 5, the limit of a constant is just that constant. It's 5. Okay, and then all of our algebraic rules for limits. So say we already know, somehow we've already proven the limit as x approaches a of f of x is L. We've given that a name. And we've given the name to the limit as x approaches a of g of x. We're calling that m. We already know both of those. Then this rule says if I've got f plus g and I'm taking a limit, I can distribute the limit and do it one at a time. And pretty much anything you can do with addition, you can do with subtraction, and that's all this says. You can distribute a limit over addition or subtraction. This rule says if you've got a constant times your function, you can pull that constant out, do the limit, and then just multiply by your constant. These three rules together right here say that the limit is a linear operator. You can distribute it over addition and you can factor out constants. The derivative will also be a linear operator. These three rules here will also apply to derivatives later. These will not. That's where a lot of people get in trouble. These are really nice for limits, but they don't work for derivatives. This says if you've got a product of functions, you can just take each limit one at a time and multiply the answers together. This one says you can do the same for derivatives, or sorry, for fractions, as long as that limit on the bottom is not 0. This one's really important. You're only allowed to split up a limit top and bottom as long as that bottom limit is not 0. Otherwise, this is not a true equal sign. This will not work. And we'll see some examples today. And then these two rules can actually be generalized. Once we talk more about continuity, we're going to generalize these rules. And these say, really what they say is, if you have your function and it's inside any continuous function, you're allowed to bring the limit inside the function. See, that's what happened here. The function's being raised to n, and then we're taking a limit. We've swapped the order. I'm saying you can take the limit first, then raise that answer to the power n. And the same works with radicals. And we'll see later that this actually works with any continuous function. Okay, let's do some quick examples here. So I'm going to write these out step by step in agonizing detail. We're going to do this like once or twice. And then once we start to realize what's actually happening, we're never going to go through all these steps again. So you'll have like one question on the homework. You have a group assignment. where you have to go through all these steps, and I want you to write them all out. But then moving past that, once we get that turned in, you'll see that we don't have to go through all these agonizing steps. Okay, so let's write this one out. First, I have a rule that says if I have addition, I can distribute a limit over addition. So I could write limit as x approaches -3, it's a -3, of 4x plus limit as x approaches -3 of 2. Now one of my rules says if I've got a constant inside my limit, I can bring it outside the limit. This one I can just do. That's a constant. That's my second rule up here. The limit of a constant is just that constant. So the limit as x approaches 2, or the limit of 2 as x approaches -3 is just 2. And this one is the first rule. The limit of x as x approaches -3 is just -3. So let's see, what is that? -12 plus 2, I think we get 10. Now I want you to notice at the end of the day, what did I actually just end up doing? At the end of the day, I ended up just plugging in -3 for x. Like I went through all this work to get there, but that's all I really did was just plugged it in. Oh, and I think that's -10 there, isn't it? Yeah. Okay, again, let's do this one. Going through all the steps, this will equal the limit as x approaches 2 of 2x squared minus 3x plus 1 over the limit as x approaches 2 of x cubed plus 4. Now, I don't know if this equal sign is true. I may have just lied to you. It depends on what we end up getting here on the bottom. If I end up getting 0 on the bottom, I was not allowed to even do this step to begin with. So maybe we'll put a question mark here because we're not sure if we were allowed to do that. You can't distribute a limit top and bottom of a fraction if the bottom limit is 0. But let's check. Okay, I have a rule that says I can distribute here. And I can pull out constants. I'm going to do that in one step because I don't have a lot of space here. So twice limit x goes to 2 of x squared minus 3 times the limit x goes to 2 of x plus 1 times the limit x goes to 2. I guess I'll just put the 1 here. And then same thing on the bottom, distribute the limit. And I have to write this at every step. Now, can I take a limit inside of x squared? Yes, that's this rule right here. So this will be, here I'm going to keep going. I'm just not going to do that problem. This will be twice the limit as x approaches 2 of x squared. This one we can go ahead and do. What is the limit as x approaches 2 of x? That's just 2. The limit as x approaches 2 of 1, the limit of a constant is just that number. Same game here. I can bring the limit inside the cube. I can swap the order and say this will be the limit as x goes to 2 of x cubed. And then here we have a constant. The limit of a constant is just that number. Okay. In here, The limit as x approaches 2 of x is 2. Notice I'm not writing limit anymore. Once you take the limit, once you actually calculate the limit, you don't write limit anymore because you've done it. You've fulfilled that operation. So limit as x approaches 2 of x is just 2. And same thing here, limit as x approaches 2 of x is 2. Now, I want you to notice at the end of the day, what did we end up getting? All I ended up doing after all of this work here is I ended up just plugging 2 in for all the x's. And we'll see in a minute that that's really what you're doing if the limit exists. Okay, and then here, let's go and calculate this. That'll be, let's see, 4, so that's 8 minus 6 plus 1 over 8 plus 4 is 12. So that'd be 2 plus 1, 3 over 12, 1/4, I think. Maybe somebody check my arithmetic there. Okay, and that's a good place to stop for this one.